In this section, we'll look at the difference between black box testing and white box testing. We'll look at how to create a black box test plan based on input ranges, and we'll look at different forms of test coverage in regard to white box testing. This is an important thing to keep in mind when you're testing. A good test is one that has a high probability of finding an error. You can't test a program with every single possible input, so you have to choose test cases that are most likely to find an error. The most likely place that errors occur is in boundary cases. For example, if you're testing a stack component, you might test the behavior of an empty stack, a stack with only one element in it, and a stack with several elements in it. If a stack with 4 elements has a problem, it's likely that a stack with 3 elements will have the same problem. But a stack with no elements might be handled differently by the implementation because the empty stack is a boundary case. And a stack with only one element in it is close enough to the boundary case that it should probably be tested as well. The objective of test case design is to try to uncover as many errors as you can, hopefully all of them, in as little time and with as little effort as you can. Writing test cases takes time and effort, so you don't want to spend all of your time writing a lot of redundant tests. There are 2 main kinds of testing for a component: black box testing and white box testing. In black box testing, you treat the component like a black box. In other words, you can't see inside the component to its implementation. The only information you have about the component is its specification. That is, the description of what the component does. For example, the specification of a Java class would be its API, the Java docs. That's why black box testing is sometimes referred to as specification-based testing. In white box testing, you do have access to the implementation. And part of your goal in white box testing is to cover all of the code in the implementation. We'll talk about what that means later in this section. The concept of test cases is fairly straightforward. Given certain input, we need to ensure that we get the expected output. The output value we expect is called, not surprisingly, the expected value. And the value we get from actually running the code is called the actual value. When the actual value equals the expected value, our test case passes. Note that it may not be enough just to check the return value of a method. If a method has a side effect, for example, we'll also have to check if the actual value of the object affected is equal to the value we expect. Another thing to notice is that the value we're expecting is based on the specification of the component. This is true even when we're doing white box testing. White box testing still has to test actual values against expected values, expected based on the specification, but it has the extra responsibility of covering statements and conditions in the code. In black box testing, we don't look at the implementation of the code. We simply develop our test cases based on the input of our operations and the expected output. As we have stated earlier, we cannot test every possible input, so we have to make some smart decisions as to what test cases to write. In black box testing, we choose these test cases based on the range of our inputs and the boundary values in that range. For example, if our input includes an integer that can go from 0 to max int, we might test inputs 0, 1, and max int. 0 and max int because they represent the beginning and end of our range, and 1 because it also represents a boundary point. It's the multiplicative identity. In white box testing, You're looking at the implementation and trying to ensure that your tests will exercise or cover all of the statements, branches, or paths in the code. You're still writing conventional test cases that check whether the actual value you receive when running the program is the same as the value you expected to receive. But now you're going to be looking at the structure of your code and using it to help you come up with test cases. You would like the test cases you come up with to cover as much of the code as possible. There are different types of coverage you can look at, such as statement, branch, and path coverage. When you see statement coverage referred to, it simply means that your tests have to cover or execute every line of code at least once. We're going to see that statement coverage is a fairly low bar for testing. With branch coverage, you have to cover both branches of every condition, the true branch and the false branch. With path coverage, the goal is to cover all possible paths through a given program.